Good morning to everyone. Myself Sandeep. Today we are going to discuss about work. The way we define work in our day-to-day life and in terms of physics is quite different. In day-to-day life, if I ask someone like what's work, they say it's just about getting tired. Right? If I ask a student what is work, it's like, sir, I work hard. Like I practice so much of problems I supposed to. So in terms of our life concerns or our microscopic world concerns, work is kind of how much effort you put. But in terms of physics, it's quite different because we always worry about how can I measure it. It's always about like quantitative study or numerical study. So we define work in a much better way or much precise way. Normally work we write it as F dot S. Okay, that means if you have to do some work, means if there is an object of mass m, if you apply a force F, and if that displaces S in a desired direction, we call it as work is done. See here, there are three important things. One is force, and the other one is displacement, and the other one is direction. So now this work can be written as F S cos theta. So as I told you, F is the magnitude of F and S is the displacement, the magnitude of displacement, and its cos theta signifies the direction between F and S. See here, it can be F cos theta into S, or else it can be F S cos theta. Example, if there is an object M, and if I apply a force in this direction, if the body displaces in this direction, yes. So I want the work in this time, in the straight. So then this angle will become theta. So this is S cos theta. So work will be Fs cos theta, right? So if I take this marker and if I want to move it like this, I should apply force in this direction. Correct? Like if I take a duster and if I push the duster upward, so that means F is this way and S is in upward direction. So it's always about the directions, the way which you are applying the force and displacement. So now you see here, this is basically a scalar. So scalar is nothing but a physical quantity which has only dimensions. Okay, we know a lot of examples for the scalars: mass, length, and of course speed, and then work. There is one more type of physical quantities that is called vectors. Vectors is a physical quantity which depends on both dimensions and direction. Okay, so example for vectors, the common example we know: velocity, acceleration, and torque. So now let's discuss about the units and dimensions of work. Work is normally we use it as joule or J, capital J. So the force into displacement, right? So the dimension of force is the unit of force is Newton and displacement unit is meter. So it's basically Newton meter or else kg meter square per second square. And dimension wise, Newton dimension is m l t minus 2 into l. So it is ml2 t minus 2. Okay. So here we will discuss some special features or the special cases of work when work will be positive and when work will be negative. Of course, yes, work, even though it doesn't depend on the direction, it can be positive, it can be negative, but it completely depends on the direction, the way you want to work. Now, when work will be positive? Okay, I'll try to explain these two examples or these two cases in terms of gravitational force. See, like when I take this marker, if I lift the marker up, right, or if I leave this marker down. So now you see the marker is falling down, the displacement is in the downward direction, and the force, the gravitational force also in the downward direction. So what is the angle between them? Of course, the angle between them is 0. So cos theta equals to cos theta becomes 1, theta will be 0 degree. Okay, so now the work is purely F, yes, the magnitude of F into magnitude of S. So when work will be negative, see, in terms of the same gravitational force, if you take it as an example, if I lift this marker up, okay, so observe carefully, the force is acting downward, the gravitational force is a centralized force, it always acts downwards, so the gravitational force is acting downwards and the marker is moving up. Okay, so that means the direction of the marker or the force, gravitational force is downwards and the displacement direction is upwards. So now what is the angle between them is 180. So cos 180 is minus 1. So what is minus F? Yes. See, this is purely about dimensions of the magnitude and this is purely about magnitude. So you can just mention it as Fs, there is no problem, or mod F into mod S. So the same way work can be 0, when work will be 0, like if there is no displacement or if there is no force, and the same time when the theta is 0. This is a very special case to understand. See, when theta becomes 90, the work will be 0. So what is meant by theta 90? So like example, like when a pulley carries a weight and moves forward. Okay, so you see here the displacement is in the forward direction, but the gravitational force is acting down. So what is the angle between them is 90. So automatically the work will become 0. So you know, it's kind of like a guy pulling, he will carry through the luggage to your home, and you will say like, no, you know, your force is gravitational force is downwards and your displacement is, you know, it's in the straight line, so the angle between them is 90. So the work is done, the work is 0. That means he didn't do any work. That's why I said in the beginning, the way we define work in our day-to-day life and in terms of physics, it's quite different, and it's fascinating also. Now, another example, we'll stop it with one more example, that is the Earth revolving around the Sun. To take an Earth, Sun is the center of an ellipse, it will be at 1/4, right? So if our Earth revolves around the Sun, the displacement of Earth is always in a tangential way, force, always gravitational force acts towards the center. So now what is the angle between them? Force is 90. So cos 90 is, it's 0. So work done by this is 0. Not only this, like, you know, if you take an electromagnetic force, like if an electron revolves around the nucleus, or any, you know, if you tie a thread, stone to a thread, and if you rotate it, and even in that case also, in terms of physics, the work done by them is 0. Okay, so this is the most, you know, interesting part. Okay, so we discussed about what is work, or on what factors work depends, and when work will be positive, of course, when the force and displacement is in the same direction, and when work will be negative, when they are in opposite direction, and when work will be 0, when there is no force and there is no displacement. What is meant by there is no displacement? If there is a wall and if I try to push the wall for a hold, what is the displacement? Of course, I can't push the wall. So what is the displacement? 0. So that means work done by them is 0. And the last very interesting case to discuss in theta is 9. So examples, a pulley carrying object. See, here you should understand very carefully, it's about reference. With respect to this man, there is a work. But with respect to gravitational force, the work done by them is 0. So that's why it always depends on the reference which you are considering, and the electromagnetic force or the gravitational force. Thank you.